Hi, folks. Welcome back to Physics with Captain Rod. I'm making this one here to help you out with number 35, Chapter 7 in your engineering mechanics homework. So, kind of regardless of what the problem's about, to tell you the truth, any of these internal shear moments, you typically start by finding the reaction forces. So, start by drawing a free body of this entire structure. We'll do this over here. We're going to have what, an AY. This could support an AX, but there's no other horizontal forces anywhere, so there's not going to be an AX. We're going to have a BY here. All right, now we got to deal with this loading here. So this distance right here is equal to our loading times the distance 2A plus B. That makes the area, right, again, from here to here is 2A plus B. So that makes the area from here to here equal to 2A plus B times this. So we're going to have a single force vector here equal to W times 2A plus B, the quantity squared. I got a feeling this one's going to be an algebraic nightmare. That force vector goes 1/3 of the way from the corner. So this distance, best I can see it, is going to be 1/3 of 2A plus, 2A plus B. Okay, so now, write a moment equation about A, and you'll get B in terms of this. It'll be kind of ugly. Write a force equation, y direction, to get A in terms of this. Because remember, B you'd already have in terms of all of this. So the best you can do right now that I can see is get A sub y and B sub y as functions of this stuff. All right, now, let's deal with this internal loading at C. So now what we're going to do is we're going to cut our system like so. We are going to get rid of the triangular load. Going to get rid of this. So you're going to have an AY, which again from over here is going to be some function, and it's going to have this, this, and this in it. Let's deal with the triangle now. Oh boy, this thing does look like kind of a pain here. We're going to need this function, that load function. Now you notice it's linear when the intercept is 0, so that's our max. Divided by this would be the slope. Let's see, so it's going to have a slope times x and no intercept, and the slope is going to be this over this. Okay, so that's going to come out to just this times x. This is w as a function of x, is w times x. Okay, so that makes this distance right here equal to this times this distance, a plus b over 2. And I think that's going to make the single force vector equal to this thing's area. Let's see. That's going to be 1/2 a plus b over 2 times this thing right here, which is going to be a w, and another a plus b over 2, so that's going to be squared. And it's going to be applied 1/3 from the end, or we could say 2/3 from this end. I'm going to do it that way. 2/3 times, whoop, pardon me there, my phone. The distance from here to here is a plus b over 2. Okay, internal shear moment, and there's no normal. Now, here's where this condition will come in. It says to find the ratio A over B such that the shear at C is 0. So you're going to write a force equation. All right, here's our shear that vector right there, and there's our moment. Going to write a force equation, solve that for the shear. Some function of, it's going to have this, this, and this in it, and then set it equal to 0. And then you're not going to be able to get A or B, but it sounds like you should be able to manipulate it to get the ratio A over B out of it. So yeah, that's going to be a long, what I would call a PETA problem. And, that's just what some of these are like. So there may be a shorter, easier way to do it, but if there is, I'm not seeing it. I'd probably go with that. Have a great day.